Welcome, everybody, to our first ever Incubator competition. Woo! If you can hear me and you're not sitting by the AutoSens stage, come right now. This is where it's at. We have 7 incredible startup companies with some wicked technology, products and services to pitch to you. And it is competitive style, so we would love you all to come over and join us while you eat your lunch. My name's Jenny. I work for AutoSens and In-Cabin, programming the content you've seen the last couple of days. And I would like to start by introducing, sorry, my stutter, our wonderful judges. So firstly, we have distinguished scientist and lead imaging engineer from NVIDIA, Robin Jenkin. Please give us a wave, Robin. Second up, we have the lead UX researcher from Ford. We have Susan Shaw. And finally, our angel investor, Darby Hadley of Freshwater Angels. All right, so a little rundown on how this is going to work. Our pitchers have 3 minutes to get across their product, service, or technology to the judges. The judges then have 2 minutes to ask questions. I'm going to be standing here yanking you off the stage when you run over, so make sure you keep those pitches tight. All right, without further ado, I would like to welcome to the stage our first company, and that is Brighter Signals. Andrew, welcome to the stage. Right. Your 3 minutes starts now.
Great. Hi, Andy Klein, one of the founders and CEO at Brighter Signals. We are a sensing technology company. We have 2 primary patents on new types of sensors. What's unique about us is our sensing is made of fabric, entirely made of fabric. We have one sensor that basically does weight and position, and the other that can measure proximity from the surface. They're fast, they're highly accurate, much more accurate than all of the existing sensor technologies for weight. Highly durable, they run on low power, and most importantly, perhaps, they're half the price of existing technologies. So they're affordable, accurate, and durable. Sensors go on the seat to help figure out who's in the seat, how big they are, and what position, and are they moving, are they settled, are they comfortable. We also can embed them in dashboards and measure proximity to the dashboard. The same dashboard sensors can also become gesture control devices and maybe play a part in simplifying the human interaction. Our core application has been occupancy classification to make airbag deployments more intelligent, to meet current and future regulations in Europe, the United States, and around the world. We can also expand the functionality, make the sensors even more dense, and support advanced safety features, advanced comfort. We can also dumb them down and make newer, better versions of seatbelt reminder and child presence detection technology. We also have aspirations in the robotics industry and to be in the factories where our touch sensors can actually make robots and grippers more dexterous, and our proximity sensors can actually let the robots sense approaching people and objects. We're ready to scale through a partnership with a major supplier to the automotive industry that's got 44 factories and a 30-year history supplying OEMs around the world. And we're leading with OEMs. We have a long 5-year relationship now with BMW. That's really been our first big validation. We're working with many other OEMs in the US, in Europe, and in China. And we're partnering and collaborating with all sorts of tier 1s and other suppliers in seats, in sensor fusion, in safety systems, and other relevant parts of the ecosystem. Thank you very much.
With time to spare. Well done, Andrew. Excellent work. Okay, so over to our esteemed judges. Do you have any questions for this speaker? Yes. Or would you like a little time to confer?
So you said you've got all these relationships in China. All the U.S. car companies, I can't speak for Europe, have this demand for outside of China. Do you have a strategy that also runs your supply chain that doesn't have a dependency on China manufacturing?
Yeah, absolutely. And we can produce in China at lower cost. We also can produce at a European facility owned by the Chinese partner that we have. And our manufacturing contract is not exclusive. So if we get the opportunity, we could produce in the United States and Europe or in other less expensive markets. It's really a question of price. And for OEMs, there are some US OEMs that would prefer not to or wouldn't buy from China. We can certainly accommodate them. But many of the US and European OEMs want the price more than they care about where it comes from. And as I'm sure you know, the global auto industry and China are like this, and I don't think that's going to go away. And we are much more interested in serving OEMs than picking, geopolitical debates. We can produce manufacturing is actually not that complex for fabric-based sensing, so we think we can do it wherever we need to.
45 seconds left. One more question.
Do you get a pressure signal out, or is it simply a there or not there?
No, what's outstanding about our technology is we can very granularly measure weight. We do that by measuring voltage differential and correlate that to weight. But unlike most weight sensors in the auto industry that are binary, on, off, we actually can measure weight. Not perfectly, because the curve is not linear. We can measure from about 10 kilos up to about 110 very accurately. Above that, it kind of flattens out. But in the sweet spot, we can measure very accurately.
3, 2, 1. All right. Thank you so much, Andrew. That was fantastic. I'm sure you'll agree. Lovely. Okay, moving on to our next speaker. We have embedded AI. Rico, come and join us. All right, give it up for our next competitor. Your time starts now.
Hello, everybody. Thank you to be here, and I hope you enjoy a little bit what I have to say. It is all about ultra-wideband. We are embedded AI, and we have specialized ourselves on ultra-wideband. Some of you may know ultra-wideband, some of you don't know. But all of you may know cars for keyless entry. So on the bottom left side, you see a car that is actually doing keyless entry. And what we can do with ultra-wideband is a little bit of history, This is already state of the art. And what we can do with ultra-wideband, we can search the distance from two sensors from one to each other. And you see 6 red sensors in the car, and you see the key fob is standing in front of the car. And what ultra-wideband is doing, it's searching the distance to the key fob. This is what we call ultra-wideband ranging. It's in the car since 2020, and it's really required because before we had ultra-wideband in the system, cars got stolen by relay attacks. So this is not possible anymore because we have ultra-wideband ranging since 2020. A little bit of history, but it's important to understand we have the sensors in the car. They are already there, and now we're coming to the next. This is now on the right side. You see ultra-wideband radar. Now the same sensor, the same hardware sensor can do not only ranging, what you see, it can also do radar. So all the sensors that are already in there, they can now take over functions which we already use with other sensors, like let's say radar sensors or ultrasonic sensors or something. Now our already existing ultra-wideband sensors can take over these functions, and this is a big business case because you can release or you can get rid of all these other sensors. It saves a lot of BOM costs. So yeah, this picture shows it again. On the left side, you search for the key or for the mobile phone as a key. And on the right side, we can, in the same time, we can do child presence detection in cabin sensing topics. So this graphic here shows the thing, what we can do. What we promote is the XUWB, the Extended Ultra-Wideband Automotive Platform. So this is on the top right, you see the orange figure is state of the art, is the car access, but all the blue bubbles which are coming there are new fields which can be faced by ultra-wideband. So you can see exterior sensing, like the kick gesture, which is nowadays done with a capacitive sensor. You can get rid of the capacitive sensor because this kick gesture can be done now with the already existing ultra-wideband sensors. Or you see on the bottom left side, the blue bubble is in-cabin sensing. This is what we are here for. Everyone knows we are here for in-cabin sensing. And there you see child presence detection and seat occupancy detection or intrusion detection can be done. Thank you very much.
Perfect timing. Excellent stuff. Well done. Thank you so much. All right, we don't go anywhere. Don't go anywhere, Rico. You got 2 minutes of questions from our very esteemed judges.
Hello.
Susan, would you like to start first?
Yeah, I'll start from the UX side. How does the customer interact with this, or is this a seamless experience for the customer?
It's not the kick sensor, the kick gesture for opening the trunk is an interaction with the customer, but sensing the child presence detection is not a interaction part, is more a safety part, because there are rules, the Euro NCAP rules or the Hot Car Act makes it necessary to have a sensor for child presence detection in there. Now we are using the already existing sensors, no new BOM costs, get rid of other radar costs, so this is a big business case. Yep.
What's the false alarm rate?
0.
Oh, nice answer.
Any more questions from our judges, or are we all happy? All happy. All right, thank you so much. Give a hand to our wonderful speaker from Embedded AI. Lovely. Let's move it right along. Next up, we have Vered from CorrActions. Welcome to the stage, Vered.
Hi, I'm Vered, and I'm the CEO of CorrActions. And what we do is we've developed Neuromonitor, which is a cognitive layer to detect impairment and cognitive state in humans. And we are focused on automotive. Basically, the way it works is when you're thinking thoughts and when you're performing actions, the neurons running around your head hit over here the front motor cortex. And our founder, our chief science officer and co-founder, discovered that this is manifested throughout micromotions in your body. So basically what we do is we've learned to correlate these micromotions in your body with the actual EEG brain patterns. So in automotive, we use the steering wheel, and by micromotions on the steering wheel without a camera, with a software-only solution, we're able to determine if you're cognitively impaired and which is the impairment. So we can detect specific impairments such as alcohol, but we can also detect a general cognitive brain fog, which is caused by tens of different reasons, which means you're not really fit to drive at the moment. So what we enable cars, machines down the road, also humanoids to do is to have infer the human cognitive state and whether the person is capable of performing or whether we need to monitor them and give them support so that harm doesn't happen to them. So we've been validated in automotive. We were founded 6 years ago. We spent the first 3 years just developing the tech. 3 years ago, Volvo, Goodyear, and BlackBerry became an investor. And we really focused on automotive. And our products today are alcohol detection, fatigue drivers, and distracted driving. We have, in terms of our market traction, we have 5 active POCs around the world with global tier 1s and OEMs. And we're all doing track testing at various stages. We're hoping to, by the end of the year, max early next year, be ready to announce our first production date. The advantages of our solution is that it's multi-cognitive impairment. This is very important. Also, it's software only, low compute requirements. Everything is based on physical AI and neuroscience, so it's scientific and accurate. It's less intrusive because we're not using cameras, we're using software. I think it's also important to say that we believe it's going to work in fusion with existing in-cabin sensors. So with the camera, if you want to talk to me later, we have some great results from a fusion project we did with our technology and the camera. We really reduce dramatically the false positives to nearly 0. So we've been validated. Volvo is an investor, so they're allowing us to share that on a recent blind test of drunk drivers, close to 100 drunk drivers, our detection rate was 63% with 0 false positives. And then we also did for another provider that I can't say their name, another independent test. Over there we were able to see the protocol make sure that people were drunk above 0.08, and our detection was 85% with 0 false positives. So we're very accurate. There's no errors. And it's a really validated technology that we think will scale fast because it's software. We think it's going to bring a lot of value and have high impact because we're going to save lives. And of course, it's going to be easy to deploy because it can work either standalone in some markets when there's no DMS camera, and in other markets where there cannot be a camera, it will be a standalone solution. Thank you.
Thank you so much. Okay, judges, are you ready?
Yeah, so does the system have to be calibrated for individual users? Because it seems like those micro motions are going to be unique by people.
So today we do use a short validation period. The Euro NCAP requires detecting within 5 minutes, so we're well within that. But we can also do it without detecting the individual and calibrating, and then it slightly impacts. We always keep the false positives at 0, so it slightly lowers the detection, but we're easily within the 5 minutes for each person, so we don't need like pre-data. So it's per person, but the models can also work without knowing who the person is, and then it's just slightly less accurate. Still 0 false positives.
All right. We do a lot with PII, personal information. How are you gathering this information? Is this being shared with the police if someone's drunk, or is this notification go to the driver, or what are you doing with that personal information?
So as I said, we still don't have a product in market, so it's a theoretical answer. Our objective is to save lives. We don't want to report it to anyone. We don't want to share it on the web. It's an edge solution on the car that's going to either give, if it's a cognitive distraction, for example, we can detect if your eyes are on the road but your mind is elsewhere because you've had a fight or because you're stressed. So only you as a driver would get an alert, but if we detect that, for example, you're fatigued or you're drunk, then the ADAS systems need to engage to increase the safety. We're not going to report to anyone. We don't want to get into any personal information. We just want to make driving safer. And I will add that I personally have lost 2 family members to impaired drivers, and I see this as my personal mission to make it happen. We don't want to report it to anyone. We just want people to be safer.
Susan.
So you said you can detect 0.08, but people become impaired lower. What's the lowest level you can detect?
So the interesting point is that we found that at, let's say, 0.05, some people can drive. They're fit to drive in a way. They're not perfect, but they're fit to drive, and others are not. So we found that 0.08 which is the legal limit in the US, is a great level because very few people can really drive at that level. And so it's a good point. So we say you're sober or you're above 0.08. The reason we do that is because we're really focused on, specifically for alcohol, you don't want to have false
I'm
positives.
so sorry. I'm going to have to cut you off there, but thank you so much. That was an excellent presentation. Fantastic. All right. Our next presentation is coming up from SDVerse. Please welcome to the stage our speaker. All righty. Now, I'm going to make sure you're ready this time. You've got your mic. You've got your clicker.
I got my mic.
You've got your screen. Are you happy?
I'm very happy.
Thrilled. Okay, let's go.
Is everybody happy? All right. Jeff Walker, Chief Commercial Officer, SDVerse, a startup company that was founded 2 years ago by General Motors, Magna, and Wipro for the entire automotive global industry. So what are we? Every mobility solution in software needs to find a home. The OEM, the tier ones, and even other players, a last mile commercial vehicle, and they need to find that software solution in a quicker way. If we're going to compete globally, we need to shorten the development cycle. And a key part of that is early discovery. You don't have to fly around the world, have endless tech shows. You can do it all in the discovery of your laptop. So that's what we're providing. An AI-powered search, secure, private, and in minutes and on target, finding exact details that you need for your automotive needs. There's a spec match solution that we just launched. It's amazing. You load a 200-page spec up into the marketplace, Bosch, Valeo, HL Mando, 80% match, 75% match, 60% match. And where are the gaps? It analyzes all of it for you. So it's really amazing. It's a collaboration hub. How do you communicate with the person on the other side? How do you talk to them without having to fly jet fuel around the world, have a meeting? We have a built-in collaboration hub. And then finally, we do more than just online. We like to get everyone together, have human contact, have relationships built, really talk to the decision makers, talk to the innovators, and get people together. So it's really a powerful collaboration tool SDVerse is all building. So please come join us. We're one of the fastest growing business-to-business marketplaces in the world. We are in the top 5%. You can see who is on our list. We're talking to many global OEMs. We're talking to many global tier ones. And we're really, really doing well. And we have proof cases already of making those connections count. So that's SDVerse in a nutshell. Thank you very much.
Wow, excellently put, well done. And now to our very esteemed judges who I see are taking excellent notes. You got a question for us?
So it seems like this is ripe for competition. What's the competition landscape look like?
There's not much competition. Usually they're built by selling cloud services first, like Azure, for example, AWS, I would say is a good example. But they sell basically their cloud services, part of that, and take a commission. We're a flat fee based on the size of the organization. We don't get involved in the deal at all. We don't take a brokerage fee, license fee, or anything. We just want to make sure the listing is pure, technical, found, and it's one flat fee. So we don't have anyone competing with that business model.
All good? All right. Thanks again. Thank you, Jeff.
All right, thank you.
Fantastic. That's perfect. All right, coming up next, we are halfway through, but not done yet. Can I please welcome to the stage Attentia Drive? Are you feeling okay?
No, yeah, I'm good.
Okay, all right. You've done this before?
Yeah, I have.
Only the youngest ever exhibitor at CES, I hear.
Yeah, well, we'll talk about that soon.
Okay, all right. 3, 2, 1, go!
How's everyone doing? All right, so this is Attentia Drive. So I'll just give you a quick background about what it is. So we are a distraction detection prevention dash cam that sits on your mirror and looks down at you while you're driving. Here's a quick mock-up of what it looks like. So how it works is, for example, if you show any sort of inattentiveness or you look drunk or you look like you're distracted by being on your phone, we send you a quick immediate audio alert off the device to start paying attention to the road. So the biggest problem is, it's been probably said 100 times, distracted driving is huge. Over 3,500 deaths a year in the US happen because of distracted driving. Tons of people die. 1 in 4 car crashes are because of phone use and distraction, and it's a massive problem. So as I explained, we are a device that sits on your mirror, looks down at you while you're driving. If you stop paying attention or show any sort of inattentiveness, we map out your face. We can see if you have a phone. We can hear if you're on a phone call, or if you're not paying attention, we notice that. We won't alert you immediately. Our biggest thing is we are based on the context of how you're driving. So for example, if you're going 80 miles down a highway, right, and you look pretty chill, there's not that many cars around you, and then you pull out your phone, we won't give you an immediate alert. But if you stop paying attention, but if you're going to a busy intersection, stop and go traffic, and then you pull out your phone, we will give you an audio alert. Our biggest ICP, our main target customers, is parents of teens. They want this product the most. They want to keep their kids safe because right now, teens drive terribly. You might have heard youngest ever at CES. I'm currently 16 years old. So I just started driving like a couple months ago, and it is a huge problem for me and all my friends. Distraction driving is a massive problem. The other feature that comes with our device is an app. So we have an app that connects with the device. It'll show you driver reports, alerts, when they were distracted, how long they were distracted, how often they're distracted, stuff like that. The biggest thing, so currently we're for parents of teens. The next biggest market for us is insurance companies. So the main target demographic for our device is cars before 2025 or lower tier cars. So we're for like the 2016 Honda Civics, the 2018 Toyota Corollas, the cars that don't have the latest tech. That's exactly what our device is trying to solve. So yeah, smart driver reports, personalized experience, and insurance sync is one thing we are striving to reach for. We're talking to Geico, State Farm. They love the idea. They love having increasing better tech to older cars because it helps, evaluate the risk better of older drivers. of older cars, and it makes older cars smarter, and they have more data. So the business model right now is direct to consumer, straight to parents of teens. We go on Kickstarter in a couple months, and that is our first initial market. The next biggest market is rental car companies / insurance fleets. Rental car companies have older cars, right? Tons of them, and they don't have this tech. If we include this tech, they love the idea of it as well. Another huge thing is Turo. Have you heard of like rideshare, rental rideshares sort of thing? It's a really prevalent problem, and especially because they have older cars. This tech is essential for them. I'm guessing I don't have that much time. Okay, all good.
Can we get a round of applause for Prahas, please? All right, questions from our judges.
You're looking to see if you're distracted, like you're on your phone, and you're going to send an alert to the phone that makes them want to look at the phone
No.
to say.
Oh, I should just clear that up. We send an audio alert from the device to the person, so it's like an annoying beep sort of thing, and then it'll prompt them to put their phone down.
I'm going back to the question I asked before about personal information being shared. You said you're going to share this with insurance companies. Are they going to offer a discount or
Great.
some sort of rate to be able to share this and hack into your system?
Great question. So it's like an opt-in system. If you want to share it, you can. We don't record any video. That's the biggest thing about us. So all we do is we record timestamps of when you were distracted, how long you were distracted. We will not send any video anywhere. For safety, like child safety is a huge thing. So we will not leak any video. It's just, we can see you're distracted this time. We'll tell you you're distracted, and on the app, we'll send you a report.
All right, so now I have a follow-up question to that. Since you said you're not recording, have you looked into recording and providing that information for accidents to prove that I was not distracted, and therefore I shouldn't get the ticket? Is that something you've looked into? Or maybe they were distracted and they get the ticket?
I feel that is we've thought of that as well.
Opposite, yeah.
That's like the opt-in system, but we will not share any video. That's like the biggest thing. Like we will not share any video for safety concerns. We'll show on our device, oh, you were distracted, you got in an accident at this time. If you want to share that, if you don't, then that's up to you.
What's your false positive rate?
So we're right now like a 93% accuracy rate. The biggest issue with us is like because we're teens, I don't know, like the low light accuracy is really inconsistent, and that's why our product could be better. That's why we're like looking to develop it even better. Include more IR sensors, or maybe partner up with people that have been doing it longer. So yeah.
All right. That's the last question, I'm afraid, but great job. Thank you so much. Congratulations. All right, next up, we have slow exit. Fair enough. Love your confidence. We have Retrospect. Please welcome to the stage Michael Woon from Retrospect.
Okay, thank you. All right,
Let's go.
We'll begin. Okay, so imagine you are a parent of a 9-year-old child, and you're dropping your child off at your elementary school that you go to every day. You see your child walking across the street, and all of a sudden, out of nowhere, an autonomous vehicle comes to your impression very quickly and strikes your child as they're heading to school. This happened earlier this year in Santa Monica, California. This is a terrible situation that no one wants to be involved in. Retrospect flew out to investigate that site to understand what are the driving behaviors and patterns around that school. I personally talked with Beatrice, the school crossing guard there, to understand the history. In her 20 years of being a crossing guard, she said she had never had any accidents that involved a child being hit until an AV showed up in January this year. So, as a parent, what sort of data would you like to have? What sort of conversation would you like to have with the driver who just struck your child? Now, maybe your child was running across the street instead of at the crosswalk or doing something else, but when you have an autonomous vehicle there, you're really left with nothing, no answers, and you need to get that information quickly. So what does Retrospect do? This pitch is not so much focused on the technology. I have other slides and lots of stuff about our technology. We've been working on this for 8 years. What we're really focusing on now is getting to market quickly and understanding the public-private partnership that needs to happen in order for commercial AV to scale successfully. So what we do is we can analyze these nuanced situations. We're showing here actual data from Austin, Texas. We were called down by the city regulators there to investigate some difficult intersections that they had with autonomous vehicles and other pedestrians. Our technology is able to, in a standardized way, determine what are the risks drivers are actually taking as they're moving through a scenario, and what are risks that pedestrians might be taking, and how can we understand who may be at fault or who may be needing to provide some more caution. What we focus our technology on is then running on board every autonomous vehicle and being able to provide an edge validation of how well the system is anticipating risks and mitigating those appropriately. So we act as a third-party intermediary between all the different AV technology companies, whether it's robots and the different government regulators, and we provide what is being required by all the regulations currently. They're all saying the same thing, from the UK to California this year. They're all saying we need you to monitor real-time risk. We don't want to hear how many accidents have been reduced over time, and we want third parties to do that on the principle of independence and trust. We knew this 8 years ago when we started. We knew this was a solution, and right now we're working on demonstrations with the state of Michigan to make this happen. This is the size of the markets that we're looking at with our 3 verticals. Obviously, if we get away from L4 autonomy into L2, L3 ADAS, we get a much bigger piece of the pie, and we're looking for partnerships and potential investors. Thank you.
Very well done. Thank you so much. Our esteemed judges, do you have any questions for this competitor? I think we're looking pretty good. You happy? We're happy. We're happy. You explained it so well. Thanks so much, Michael. Another round of applause for Michael, please. Thank you so much. Fantastic. And last but by no means least, please can I welcome Yasp to the stage. Round of applause. After this, of course, our judges will take a couple of minutes to confer, and then we will announce the results straight away. You've got your microphone here. You've got your you're not clicking.
No, I'm not clicking.
You're not clicking. All right, then let's go.
Hi, my name is Reza. I'm the CTO at Yasp. So I want to walk you through a problem. All the autonomy companies, what they want to do, they want to build an AI model that runs your robot. But they have a research team that builds an AI model using NVIDIA servers. It works perfect on their GPU. I actually have a hat that it works on my GPU. But when it comes to deploying it to the target hardware, they have a deployment team. That deployment team takes that model and wanted to deploy to the target hardware. It doesn't work. They need to spend months making layer support, making the low-power chip, adapting to the model, and then at the end, the performance is not there. The accuracy is not there. So then they spend a lot of time debugging it. At the time they're done and the model is actually running on the target hardware, the research team has come with a new model. So the process repeats again. What we're building at Yasp, we're building an agentic AI compiler through autonomous agent tools. We call them Chronos and Gaia. These tools will look at your model, identify the layers that are not supported on the target hardware, or the ones that are bottleneck. They're not running as fast on the target hardware as they should. They're using an agentic system to develop them, and we have the tool that we are very proud of is our evaluation tool that makes sure every layer and the whole model that is developed by the agentic system is accurate. And when we get to a kernel that is fast and accurate, a layer of an AI model that is fast and accurate, we combine all the models through our Chronos product into one binary, and we hand the binary back to the customer. They can just deploy to the target hardware. So we're removing months of engineering work into hours. And what is funny about this, I was showing this product to a customer yesterday, and we showed that their model is running now 3x faster. And we had a meeting with them this morning. And in the report, it said 6x. And they told me, you made a mistake. What you showed me yesterday was different. No, the autonomous agent was running overnight and was able to find 2 matmul operations that can be reduced into 1 matmul and reduction, ended up running that specific layer 9 times faster, the whole model 6 times faster. So your engineers, the autonomous agents that we're building for you are working for you 24/7 to make your models running faster on your target hardware. And that's the problem we're solving at Yasp. Thank you.
Oh. Well done. Thank you. Any questions from our judges on this one? You look like you're thinking about it.
So part of your agentic optimization of the model, does that include, say, going from floats down to FP4 or int4 and things like that
Great
as well?
question.
Or?
So we were deploying on a Blackwell GPU, and now you want to go to Orin. Orin has int8 tensor cores. So our agentic system would know already and start developing int8 cores and start calibrating your model for quantization to int8, and then the model will be deployed so that we use the most tensor cores. Basically, all the hardware has to offer on your target. We wanted to use it. We want to maximize the occupancy on the GPU, maximize the occupancy on the tensor cores to get the best frame rate on that model. Yeah.
Right, one more question.
But during runtime, everything's dynamic. So how do you manage the dynamic case?
A good question. We try to keep it ourselves at the compile level. So we get to the model. The model is a binary that, let's say the dynamic shapes, it can take dynamic shapes, it can take dynamic inputs, but the model itself is a static binary. So at that point, we hand it to the customer. We are adding tools to be watching the inference during the inference time to make sure how the model is performing for our cloud, because we have the same set of tools for cloud as well. And we're adding, let's say, based on your sequence length is changing, we adopt the model, we change the kernel on the fly, and we have a new model now running faster for the request that is coming in.
All good? Wonderful. All right, let's give our last speaker a round of applause. Thank you so much. All right, it is now time for our esteemed judges to confer. I'm going to vamp while you guys have a quick chat. When you're ready, give me a wave and come up on the stage, and we can present the trophies to the winners from today's session. So by a way of applause, this is a brand new session to AutoSens and in-cabin, and I would love to hear, did you guys enjoy that?
So for first up, we are going to do innovation. And for innovation, we went with CorrActions.
Congratulations. Please come up on the stage and collect your award.
I think you guys should get out the award.
Where's our photographer? Wonderful. Thank you so much. All righty.
Congratulations. The next one we have for scalability, we have brighter signals.
Fantastic. Welcome to the stage. Well done, Andrew.
Guess what?
If you guys haven't been over to their booth yet, I highly recommend.
Thank you very much. Thank you.
I recommend going over to everyone's booths if you haven't already. Awesome. All right. And finally, Susan.
Yes. Last but not least was for impact. And we had...
Drum roll, please.
Drum roll. Retrospect.
Congratulations. Michael. Fantastic work.
I think you need
Great.
a couple extra pictures of the other judges.
Yes, thank you so much. Can I get all of the entrants up and the judges up on the stage for a photo opportunity? Audience, thank you so much. You have been fantastic. We've really enjoyed having this session. And shortly we will be having our next presentations. But let's get a group photo with everyone. Come on up on the stage.